What's up, everyone? This is Dr. Jax. Today we're going to be looking at the Milikan oil drop experiment. What Milikan did in his experiment was able to justify the charge of an electron, which we call the elementary charge. And in order to do so, what he did was use a container to what you see on the right. In the container, he used an atomizer to spray oil droplets into a container that had a parallel plate set up along with an X-ray being shot through it. When X-rays come in contact with oil, it gives them a negative charge. What Milikan did was set up the parallel plates so that the bottom plate had a negative charge and the top had a positive charge. Once the oil droplets became negatively charged, they would be repelled from the bottom plate and attracted to the positive. This electrostatic force would allow the oil droplets to experience a force going up, at the same time while they had gravity pulling them down. Under normal circumstances, without the parallel plates, the droplets would fall to the ground. However, when the added electrostatic force took place, you'll see that the oil droplets, in some cases, slowed their fall, in some cases, hovered and stayed static, and in some cases, actually changed directions and went up. If you look at the screen on the left, you'll see this effect. And as the parallel plates start, you'll see a voltmeter show that the voltage is taking place. As the pellets experience the voltage, they will be pushed up and in some cases hover. And this is how Milikan was able to calculate the electrostatic force. If the pellets were to hover, we know from our study of Newton's laws that a hovering pellet in the middle of the air would be in a state of equilibrium, which means that the force of gravity would be exactly countered by the electrostatic force pulling it up. Based on that, if we know that the two forces are in equilibrium, we could then calculate the charge on the pellet based on the mass and the charge of the plates. From this, Milikan was able to run multiple experiments calculating the charge on the droplets. Over time, what he found was that every time he calculated charge, it was always a multiple of the elementary charge, which we know is 1.6 times 10 to the minus 19 coulombs. So what you're going to see as I run the experiment, that without voltage being applied, the droplets fall straight down due to gravity. Once the voltage is turned on and the plates become charged, you can see that they change direction and in some cases hover. And based on this effect, we're able to calculate the two forces and then the charge. Notice as the voltage gets cut off, the droplets begin to fall again due to gravity. And when the voltage is turned back on, they again begin to rise or again stay suspended in midair.